It's great to be here. Certainly an honor to follow someone as well-versed in soil health and spent a career working on these things like Wayne has. It's a tough room, though. I'm looking out here at my boss. I'm looking out here at people that work with me and know me way too well. So I'm going to have a hard time getting away with things. But I want to take the thought on the science of soil health and digging a little deeper here now. Wayne introduced a lot of the reasons why. Why was Jane this morning so emphatic how important this soil health movement is to agriculture? And so it's not just an emotional thing, the science supports it. The reality is we're at a pivotal point where we have such opportunities. We now have some actual funding and some groups with funding to help further the science and the practicality of some of these systems. And so I'm going to try to pull some of the scientific data, and this has kind of been a challenge of mine most of my career, and I'll full disclosure, I've spent most of my career in the Midwest, so I'm in the Corn Belt country, so many of my slides will look very corn and beanish. So I'm going to have Jimmy, if he's still in the room, he's going to throw something at me if I get off key for Oklahoma and some other places. But we have to take some of this science and put it into practical application, because ultimately if we figure out why we should chase soil health, then we got to figure out how to practically and logically and economically get it on the landscape. And that's why we have these wonderful farmers, like we had one of the best panels I've ever seen put together this morning. Why we have to rely on their help and input to get the practical application. We still need the good science and try to get that integrated, but we have to try it and evaluate it on real life of farms in commercial systems. And so the culmination of my slides comes from being able to work with wonderful farmers like Dan DeSutter and Rodney Ruan and some of the farmers that you see out here in this room that I've had the privilege over 35 years to get to work with. So you combine that with a lot of the really great scientists I've had the privilege to work with, and hopefully that's where some of the practicality and logic of these maybe will come through. We need to talk about the soil health. What is it really is a definition, and NRCS has a definition, and we've worked with a lot of the other sponsoring and soil health organizations to kind of come up with this and have a consensus on this. And so I want to go through this. I think a definition has to have, each word in that definition we hope has a little bit of meaning behind it, especially a short definition. This is the continued capacity, and we say the continued because this gain that we can achieve in soil health is fragile. And so we don't get to just have our soil health one day and then go back to what we were doing and we got our soil health and we're good to go. It's a very fragile thing, and so we have to continue our efforts. It's a continued growth. And so it's the continued capacity of a soil to function, and then we've got to think about soil really has some really key functions. So we want that infiltration, we want that water holding capacity, we want the nutrient cycling, we want all those functions that are very driven by a living ecosystem. And so if we can't manage our soil as a living ecosystem, we will lose some of those functions, and it will not be we will lose that continued capacity. So everything about this soil health definition has real meaning as we go through. It's not just a bunch of words, but we have that continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. Okay, so there's a lot more there than just a few words on a piece of paper, but this speaks to a continuity of message that as we see this advertised and see these words in magazines and things, we hope that everybody in this room comes back to this kind of an understanding of what it is we're really talking about with soil health. Because it's popular enough, it can get pulled off into some different rabbit holes that really may not be truly what we're all working toward in the way of soil health, okay? So the principles Wayne talked about, we've used these, maybe different words, but they all have the same general connotation. We want to minimize disturbance. Wayne went through no-till, we talk about that. We maximize soil cover. we've got to have that cover to protect and moderate temperatures and protect the soil from evaporation losses, things like that. Maximize diversity. That's been probably our biggest challenge in corn bean country, is try to corn beans, that's the rotation, and that's not very diverse.
Continuous corn too.
We do have some continuous corn. That's another. So diversity is a challenge, but that's where some of these cover crops. That's why we're at a cover crop conference, and that's why so much interest exists there to provide a more balanced diet to the microbes and the soil organisms that are so critical to that vital living ecosystem. Okay. So then we would like to have those growing plants and those living roots there more often if these are feeding, if this is the feeding pathway to take the sun's energy and get the CO2 out of the air and get that carbon down into the root zone to feed these organisms, then we'd really like for those roots to be there a little more often than the 3 minimum months in the summer where we're just growing corn and soybeans, okay? And really, the active root growth during that time is even narrower probably than 3 months. So we're really not taking advantage of the full season. So as we look at this, we say that these 4 principles are the foundation for building soil health. If you have these management principles in the back of your mind, with every operation, with every management decision, you will probably start moving the needle on your soil health to a better place. We look at these 2 on the right as our, the protection principles, if you will. These protect the habitat. These protect raindrop impact. These moderate temperature. These are the protection. If we're truly going to really grow and improve and enhance soil health and organic matter, then we're going to have to go beyond that, and we're going to have to diversify the food that we're going to provide to the organisms. We're going to provide it more times during the year if we're going to truly then build organic matter. And see, that's been the game changer. We worked on no-till alone for a very long time. I spent most of my career just looking at no-till, trying to get that system to work on the land, worked with a lot of farmers. The game changer came when we finally realized the biological benefit and how much that additional living root and diversification can do for that system to take it to a whole new level. And so these other 2 are the growers, if you will, as far as our principles go. And I have to ask, I don't know how many, we've got several farmers in the room, I know, because I know you're farmers. If I'm asking a farmer today, almost every farmer has either got a yield monitor on their combine or they've certainly seen yield maps and looked at yield maps. Have you ever seen a place on the farm where these 4 principles are in place? Okay, and so I'm going to ask you, we have a thing in Indiana, our State Department of Agriculture sponsors a program called In-Field Advantage. And the participants, it's an outstanding program where we look a lot at our nutrient management, but it gives us some aerial photography at key times, and they use enhanced resolutions to look at things. And so we look at these maps right at silking time for cornfields, and we look at this, and it's a kind of a typical summer in a little bit of a rough year. This was kind of one of those rougher seasons that everything wasn't just perfect. But you look at these certain areas, that are a little off color, not yielding, going to have as much yield potential. Then here's the low areas that have a little more organic matter, a little more water, so they're going to do a little better. And you see these across the field. But there's an anomaly here that I don't know if any of you are seeing or not. Can anybody see that little strip right there? So it's dark all the way north and south. Does anybody know what that might be, you that have looked at, huh?
Could be a fence row.
George thinks it's a fence row. Anybody else? I'm going to suggest George is right, because as we look at the old property line map, that's an old property line. What do we know about property lines here in Indiana where there used to be a fence row? Huh?
It's not been disturbed.
It's not had disturbance. What else? It's had pretty much continuous cover.
Growing roots all the time.
Pretty much living roots all the time, and there's a lot of diverse species there. Does that sound a lot like the 4 principles we just talked about? Now let me ask a farmer in the room, if you saw a map like this, what would you think your yield map would look like over that same area? Be the same as the rest of the field, or might it have a different color? I'm seeing some of these from the farmers in the back. The yield might be a little higher there, right? A little higher or a lot higher? So we have evidence on the farm that these 4 principles have real yield potential. There's a higher function happening there in a difficult year. You're either going to hold more water or you're going to deal with too much water at a much higher level, more resilience. Okay, so that's the fence row effect. Any farmer we talk to is going to know about this. I mean, we're talking 30 to 40 bushels better per acre, maybe 100 bushels better per acre in a tough year in these areas. So here we get to express to its fullest extent, or a fuller extent, all of that fantastic technology we've got, the genetics we've been developing over these times, and all of that wonderful science that we've been working on gets to unfold at its fuller potential where we have these 4 principles in place. Okay? And so now, if this was 90% farmers in the room, I would hope I have your attention. Okay? So we have this fence row effect. Now I hope some of you are staying around and going on the field tours. What if we could take that fence, if we understand the management it takes to get those principles on the land, what if we could take that fence row effect all the way across the farm? That's what the farmers you saw on that panel are beginning to understand. And if you go out to Jack Maloney's farm this week, this was a tough year, 2010. When you've had long-term continuous quality no-till, and I'll talk more about that in a minute, plus very strategically and well-managed cover crop system for a long period of time, and at the same time you're worried you're keeping track of compaction and you're doing some good nutrient management, you're doing these other practices, then it is very possible to have your fence row effect move across your entire farm. And that's significant. That's not just significant for production, that's significant for environmental services, water quality, because Jack just happens to be in the drainage area that feeds into the lake, Eagle Creek Reservoir, that provides a very high percent of the water for the city of Indianapolis. Probably if you went out there right now and got a drink, you'd be drinking some of Jack's water, okay? And you can feel just a little bit better about that because of the farmers out there that you'll see tomorrow. Okay, so here are this management system. We're going to put together a collection of conservation practices that make sense from the scientific literature that we show. You saw the data that Wayne just showed you. So we're going to come up with, we're going to select those practices. They're going to be implemented in a manner that address all the 4 principles at any time that we possibly can. Now these principles, there may be a year that you do have to do a little disturbance. But you operate them so that they're complementing each other, so that in the year that you have to do maybe one little bit of disturbance, you've propped up the system by maybe enhancing the other 3 principles ahead of that to give us some resilience to get through that period. So we're gonna address all 4 principles and create a synergistic effect so that the whole of the system will far exceed the benefits of the sum of the parts of the system. And these are the parts. Science shows that even the parts have benefits, but we're not satisfied with that. We're going to have a synergistic system that works together, that the whole of the system far exceeds the sum of its parts. And it's going to be cropping system specific. So here's where I apologize to folks that's not right here in the Midwest, because most here, what I'm going to be putting together is a logic model and a strategy that is, for my 35 years here in the Midwest, but this kind of a strategy should be put and can be put together across any enterprise, any location in the nation, I believe. Okay, so we mentioned we're going to have these practices. So we've got a soil health management system. Let's say here in the Midwest, it's a corn bean rotation, let's say. We're going to achieve soil health through a quality no-till system, a strategic cover crop and diverse cover crop system, adapted nutrient management, integrated weed and pest management, diverse crop rotations, precision farming, and prescriptive buffers. Now, NRCS has this thing called a field office technical guide. Someone asked the questions, have you ever tried to define what really is no-till? I would suggest start with the USDA NRCS Field Office Technical Guide, because we have a practice standard for each one of these practices. Okay, however, it'll say no-till on that practice standard. It might not say quality no-till. Quality comes in when we figure out all of the technology. We've practiced it on numerous farms, and that's the advantage we have at NRCS is we have all these field office locations where we're implementing these practices, working with producers, using the best science and best accepted technology available to us, working with the farmers, and then evaluating how did that work and coming back to the drawing table and making improvements. So when I say quality no-till, and I urge you to look into the literature just like Wayne presented, but look beyond just the literature and the conclusions and see if you can isolate, was this truly a quality no-till system that was put together here, or was this just a system that showed data from the absence of tillage? I get very, I guess, I'm old and cranky, but I get nervous and upset a little bit when I hear no-till spoken of as though it's a thing. That no-till's the same wherever you're at. It's just a thing. It's a practice. We put it out there. Maybe we could order it from Amazon Prime and it'd be delivered at our door. It's just a thing, right? The farmers in this room, the top producers, have worked out unbelievably dynamically managed systems for the optimization of these practices, and we've worked together with them, and a lot of the scientists then come back to the table with them and we work on these. And so that's why I have a descriptor by every one of these practices. I don't believe any of these practices are just a thing. They all have to have really a lot of effort and strategy put into them so that they work correctly. So if I'm going to put no-till on the land, I have to understand that I can't just stop tilling. If I stop tilling the soil, I'm going to change the carbon cycle, I'm going to change the nutrient cycle, so I'm going to have to adapt my nutrient management to complement the no-till system. If I don't, the no-till system may not go very well, okay? And so once I do that, then if I decide one day I'm going to integrate cover crops into this system, then all of a sudden now my planter may not plant into those cover crops. I may have to adapt this system a little bit. That may also change the immobilization and mineralization of my nutrients, so I may have to further adapt my nutrient management. So these two have to complement each other. I'm gonna change up my rotation, or I'm at least gonna make sure that my cover crop is prescribed to complement whatever my next crop is. Okay? And then further, in this crop rotation, I've got to make sure that my nutrient management is still complementing that rotation. And then I'm going to adapt new technology. I love all of our new technology. By the way, if you ever need to sneak up on a farmer, come up on the right side because he can't see you. Because he's got dashboards and iPads and monitors and everything all over. Anyway, but we've got this wonderful technology that is available to us that honestly, when we tried to no-till back in the 80s, when we first started no-tilling in the 80s, we didn't have any of this. It was hard. But man, we've got technology today that we can control the weeds, we can put nutrients exactly where we want them, when we want them, we can put seed exactly where we want it, when we want it, and so that new technology is critical. We also, and it was mentioned briefly this morning, we have to have different integrated weed and pest management strategies. We don't need to just be pest scouts. We need to be just as good at identifying the beneficials that would love to eat our pests and don't kill them unnecessarily. Okay, I just got to say that. But same thing with weed control. Weed control may be more than just chemistry. I'm all for good chemistry and working different modes of action and things, but understanding how to manage that cover crop is now part of your weed control potentially. So these things all need to complement each other and work together. Okay, you get that? You can't just do one thing, unfortunately, in this system. It hasn't gone well when we do that. You know, there's a saying that if you tug on one string, you find out that it's attached to the world. You know, so when you change one thing in this dynamically managed system, you're going to have an understanding what else you're affecting out there, and that goes for any kind of a cropping system, whether you integrate livestock. Whether you're running longer rotations, shorter rotations, vegetables, whatever, you're going to have to match your enterprise wherever you're at in the world to come up with how this complementary system can be put together. If you do that in a logical and practical manner and use the best science available and the best accepted technology available and best practical application understanding from your network of good farmers and people like that, then we would expect you would have improving organic matter. And I use the word improving because really improving is what happens more than increasing. If organic matter is not a thing either. Organic matter is all-encompassing, many pools at many different places. It's not, I know we see it as a test line on our soil test, but the reality is organic matter is far more complex. So you're improving organic matter, you're improving aggregate stability is so important, and many of you have seen the aggregate stability demonstrations that we do. Because when you do that, then you start increasing infiltration, increasing available water. That's far more important than water holding capacity. Available water means that plant has far more places in situ, in that field, to go get water. And in that water is a much better diverse nutrient supply that is in that solution that's down in the soil, deeper in the soil profile than our soil test a lot of times. And so this is, all of these benefits start showing up, and this isn't all of them, this is a short list, but these are some of those indicators we should start seeing that ultimately build those functions back into our soil, okay? So let's look real quickly. You keeping me on time, you're going to throw something, when I start seeing you stand here, then I'll know. Okay.
I'll throw it, Barry.
I know, Scott will be the very first one to throw it. All right, so let's look at no-till, and there's a whole course that we would teach in our employees in NRCS that's at least a whole day just on the no-till technology, okay? So I'm just going to give you a few slides just to, I guess, emphasize the importance that no-till is not a thing, okay? So when I talk about no-till, quality no-till, what I'm talking about is, with a no-till system, of course, planter setup and maintenance is absolutely critical, okay? The job of that planter in a no-till system is that every seed has to be exactly the same depth, and I'm mostly talking corn here. I'm focusing a little on corn. Every seed needs to be exactly the same depth, exactly the same spacing, and try to germinate in exactly the same environment. And you heard Trey say this morning that you got to get these cover crops out there even, because if that seed is laying in a different environment, it germinates a different day. And if it germinates a different day, it comes up a different day, and a few days difference is not a good thing for corn production, right? We've got that data is very clear, okay? And so as we look at the technology that I was talking about, we now have multitudes of different kind of attachments. There's some downstairs for you to look at, all kinds of, whether it's row cleaners that you need or other attachments. We can control the depth of all these, the down pressure, on the go, sub-second, real time. We can change the down pressure of some of these to make this. We can control if we're going to use starter fertilizer, and a lot of these systems need starter fertilizer. We may have to change that planter back, and I'll tell you why when I get to the nutrient management issue. But precision placement of those nutrients is critical. If it's needed, then it's critical. We have these kinds of instruments that literally are measuring the down pressure, and row by row can change in a sub-second interval, change the down pressure as we go across a hard spot in the soil, so that we absolutely put soil, every seed exactly the same depth, no matter what the soil condition is right there. Now, why am I harping on that? When we switch to no-till, isn't seed depth placement important in all tillage systems? Well, let me ask you a question. If I've just run a field cultivator in the spring of the year through bean stubble 3 days earlier, What's the temperature and moisture in that 4-inch zone? Is it very much different? You've fluffed it up, you've let air in, you've let the moisture out, and now it's the same, pretty close to the same temperature and moisture. So anywhere I put that seed in that zone, it's going to kind of germinate within a day or so of the one next to it, right? Let's switch to no-till. If I put one seed an inch deep and the next seed next to it 3 inches, because one was in a harder surface and one was deeper, what's the difference in temperature between 1 inch and 3 inch in a no-till situation? It's a lot different. What about the moisture and the temperature are a lot different. What's that mean to germination? It can happen over a 5-day period rather than within a day or two of each other. What happens to a corn plant that germinates 5 days later than the ones next to it? It's a very expensive weed, right? It's a very expensive weed that you just paid a lot for that seed. So, no-till does have a more important challenge there, so it is very critical that we have this kind of technology and understand what we mean when we say quality no-till. These are just a few things that we would put into that, under that umbrella of a quality no-till system, having that understanding. So an adapted nutrient management system, okay? So we got the 4 R's, right? What else do we need? It's the same for all systems, right? I would suggest it's not the same. 4 R's are very, very important. Right place, right time, right source, right, Rate, there we go. 4 R's are very, very important. However, I'm going to suggest that today, based on this system, we would, if we do not include soil organic matter and the organic nutrient contribution and delivery into our nutrient management plan and our nutrient management strategy, we will miss huge portions of the strategy. We're gonna miss out on how this really plays out in real life, especially when we switch to a more biologically driven system, okay? And so I think the 4 R's are important, but I think we have to make sure that we're planning for the carbon nutrient as well in that. Other things that happen to us is, we know a lot of us think of these nutrient cycles, you know, and here's a typical nitrogen cycle diagram, and it looks very simple. We've all seen this. You know, the hydrolysis changes the urea or the organic into ammonium, and then some volatilization can happen, and then we've got nitrification. It's a very simple chemical process, right? Nobody's going to disagree with me that it's a very simple chemical process. If my microbiologist back here isn't just crawling out of her skin right now, I don't know. We're missing something, but this is a very typical schematic. Every one of these processes are driven by the soil biology. And we've already said that we're going to change that soil biology a little bit. We're going to put together a system that encourages life and changes life and diversifies life. It will have an effect on some of these cycles, and we have to understand that. It should be very, very beneficial to us. But if we don't understand those changes, and the changes in the timing and change in immobilization, then we won't catch the benefit, and we might even be burnt by it. There could even be a train wreck. A very typical one that I have to show that is very important is because so many farmers across the Midwest, I watch this happen. They don't fully understand that microbial is so important to this delivery system of nutrients. So we're used to tilling the soil, right? And when we till the soil, this is microbial activity, this is CO2 rate. We get a big flush of CO2 right after that spring tillage, right? When that CO2 is leaving, it's mineralizing a lot of nutrients that becomes a spring fertilizer application. And this is kind of the upper Midwest model. This is what happens to us. We have not always been told this, and farmers don't intuitively understand just how much the soil is delivering at that early stage of nutrient mineralization, and it's spurred by that tillage operation. Now, that's a conventional tillage. So what happens when we switch to a no-till situation? Is the mineralization, is the microbial process, is the respiration going to change? Yes, it will change. It's going to stay cooler longer. You're not going to inject all that oxygen. You're going to break apart all those organic materials. Now, however, the respiration will sustain itself much further. Now, what did I say about that respiration? It also indicates that it's delivering nutrients. The soil life is delivering nutrients and mineralizing nutrients, so it's a slower process. However, if we didn't know that this was happening, we may plant a hybrid that is a front loader and wants a lot of nitrogen up front, and when it's determining its ear size, we were expecting this under traditional. We may not have been thinking about it, but that's what's been delivered. And if we've got now a corn plant trying to determine its ear size with a lot less nutrient, if it's a little bit deficient, then that can change some of our yield potential in that field. If we don't know that, if we know that, then we can take advantage of it, move some of our nitrogen up to the front of the system, and then let the soil be our later delivery system that's far more, takes us further into the cropping system. Okay, that's just one little adaptation that we have to understand from a nutrient management standpoint that gets missed a lot in our adaptive nutrient management when we switch to one of these soil health systems. Okay, it has a lot to do with carbon nitrogen ratios, and so the carbon nitrogen, you know, we're going to further change that potentially with whatever kind of cover crop we add. So that could change our strategy, right? So what we want is plant available nitrogen at the right time, right? So we have to be very cognizant that that mineralization in the soil keeps going whether there's a plant growing or not. So that's where the cover crops come in to be that catch and release portion of our nutrient management plan, okay? So you have to be thinking about all of these at the same time so that your strategy plays out. If you overdo this early in the system, you can actually immobilize enough extra N from different cover crops and letting those cover crops grow different that it can actually work against your crop rotation. So you got to look down here at a lower C to N, maybe ahead of corn, and try to strategize and prescribe cover crops a little differently, okay? So let's go into the cover crop strategies just for a second here. There's a lot of buzz about the cover crops, and that's why we're here at this conference, a lot of us. It's all about building organic matter. It's about getting the free sunlight energy at a time when otherwise we didn't have a growing root. We're going to put some of that carbon into the soil. We're going to keep the soil protected. We're going to add diversity, but really it's kind of all about the carbon, and we're putting more carbon out of the atmosphere, putting it back into the soil. Okay, so we're trying to fill those gaps, and this is probably I would try to, if I could change this diagram just a little bit. If we really think about our summer crops, when do we first get really good root growth out of our corn crop, for example, here in the Midwest, right in the Midwest? It's kind of June before we're really getting a lot of roots, right? And then they grow all through June, they grow all through July, and then what starts happening to that plant? Okay, plant physiologists in the room? What starts happening about late July to the root system in a corn plant? What have we bred that plant to do? What are we really wanting out of a corn plant? Grain, right? We don't want it wasting any energy on roots when it could be time to switch to grain production, right? So we kind of have a corn plant that stops sending energy to the roots once it gets fully into that reproductive stage, okay? And so really this green is probably a narrower part is when we've actually got living roots and growing roots and that are feeding the soil biology. So I would suggest that cover crops even have a wider benefit than some of these graphs illustrate as far as truly feeding that biology in the soil and protecting the soil and offering all those. So I think that's where cover crops became the game changers. They truly were able to feed that herd of life that's under our feet, and it really made a difference over just a straight no-till system. And I think that's where we're seeing those benefits, okay? It's not just, it's good to get livestock back on the surface, but we got to make sure we're also, anything we're doing to feed the livestock under the soil surface. So let's look at this diverse crop rotation, and I'm gonna go into some strategies because I'm kind of stuck in this Midwest, this corn bean thing where diversity is difficult, and so this strategy example I'm gonna go through here to just kind of illustrate what I'm talking about by having a sound strategy to integrate this system. Okay, so intuitively, this isn't always intuitive to a lot of farmers. If you're a farmer and you think cover crops are good, what's the first place you're gonna plant cover crops? Just straight out of the gate, if you're thinking about it, where would you put your cover crops first? After which crop? Soybeans. After soybeans, to get that cover out there, stop erosion, right? Okay. Greatest opportunity for a train wreck, right there, unfortunately. Now, here's why. If we go out there and we see, what's this? What cover crop do you see growing here? It's cereal rye. Okay, it got a little tall, gave us good erosion control. What nutrient is rye really good at sequestering based on Wayne's data? Nitrogen. We already said that the nitrogen, that process, that the soil provides a lot of the nitrogen to our corn crop. The soil, no matter how hard we try, the soil is going to provide about half of the total nitrogen, not what we apply. Even with the best 4Rs in the world, the soil is going to give it about half of its nitrogen. So if you've got the cereal rye there, it's very good at sequestering nitrogen ahead of corn, and this is, you're very early in this system. What's that corn look like to most of you here that are used to seeing corn in the Midwest? Is that a good looking corn crop? Looking a little anemic, isn't it? Well, who was the first feeder to the trough? Cereal rye. So early in the system, we sometimes miss that nutrient management, how to prescribe the right cover crop, how to get some of these things optimized. And so we could manage that cereal rye a little differently to change the C to N so that we could get a better delivery of nutrients, better delivery of nitrogen. We might kill it a little bit earlier, especially early in the system. Okay? So but if we had our choice, we'd try to find a way to get a more higher in protein kind of mix of cover crops out there ahead of that corn. Now this is a bigger deal in our higher clay soils up here in the upper Midwest than what Jimmy would experience down there. He's going to have a much faster mineralization. That rye will do more to conserve the water down there. The nitrogen is not your limiting factor. The water is. And so that this is an upper Midwest scenario I'm presenting to you. That's why we've got to work out strategies every place in the state. So we're going to look at the strategy of cover crops. Which one's going to be best? Well, in this situation, a high carbon cereal is maybe not the best thing to have ahead of that corn crop, but a higher protein, a lower C to N ratio cover crop might have been a better solution. Okay, so if we time this right, so we don't over-mobilize nitrogen, or we change the timing of some of our nutrient application to offset this, then we can have a better strategy out there, okay? And so the higher protein mixes is what we like to see in this part of the world if we can get them ahead of corn. If we do that, then that corn plant, when it's going through its ear development and all the way through this, it should not want for anything. It should have high health all the way through, and if it does, then we have high yield expectations, okay? No matter what kind of terrain, this is a super highly erodible field, and look at the color and health of that corn because we were able to manage all of those, strategically manage the cover crops and the nutrient management and the quality no-till. Soybeans are a little different. We can have a high carbon ahead of soybeans, right? Soybeans need a lot of nitrogen, but do we need to apply a lot of nitrogen to soybeans? There's actually scientific evidence that shows that soybeans and legumes in general will start nodulating their own nitrogen in a high carbon or a nitrogen deficient environment. Those signals that get sent out from those plants to start fixing nitrogen happens earlier. So we see soybeans can be planted into cereal rye very high, very tall cereal rye, just like Jimmy was talking, a lot of them were talking, can plant right into that tall with a far lower penalty, and actually a no penalty. It's probably going to yield quite well. The extra moisture conservation, the extra weed control and things like that, soybeans into cereal rye is almost a win right out of the gate. So whoever said this morning, start this system with soybeans, was absolutely spot on. So here's my final strategy here, and I'll just, this is the Midwest model that I would encourage any of you in any part of the state, work with us. We'll help put one of these together maybe. Just not that it's the only way to do it, but it gives farmers a starting point that's intuitive, that's logical and practical, and so they have success right out of the gate. So if I was starting from scratch, had not no-tilled, had not used cover crops, but I was really I'm ready to do soil health, my first operation here would be, I would drill or aerial seed cereal rye after corn that's going to soybeans, okay? I would do that because cereal rye can be seeded late. It's very successful most of the time, and my next year's crop is what? Soybeans, which I've already said does really good in this cereal rye situation, okay? So that'd be my first no-till operation. My second no-till operation would be, I would find myself a soybean that was an earlier soybean. Most farmers plant a range from early to late just to break their workload, but I would find an early soybean that had good yield potential, and I would plant it early in the system, early in the season, into this cereal rye, okay? And why am I all worried about planting an early bean? Why am I wanting an early bean into this cereal rye? And why am I wanting to plant it early? I'm wanting a better window next fall to give me a better selection opportunity for different cover crops ahead of my corn, okay? And if I plant an early bean early into this really nice, lush cover crop that I've seeded, I don't expect a yield hit. We get very good yields here, at least in central Indiana, with earlier beans if we follow this situation. Okay, so that's my second no-till operation. My third no-till operation, because my beans came off a little earlier, I'm going to plant a low C/N mix after my soybeans come off, a higher protein mix, because what's my next crop? Corn, right? And so this is my third no-till operation. Okay, so now I've had 3 operations. I've had 3 plant types, crop types, maybe even 4 crop types. So I've got my diversity built. I'm starting to build aggregate stability. I've got air and water moving freely. I've improved my soil functions already before my 4th no-till crop, which is my corn that everybody worries about. So now I've got many of my functions up and running in my no-till system before my first corn crop ever enters it. And so my 4th no-till operation is my corn operation. And if I've already got all this going, I've had now 2 seasons to go to school and learn how to do quality no-till, get my nutrient management plan adapted, my pest management plan adapted. And so my first corn crop in this system has high likelihood for very good success. We're not going to expect yield drag or yield reduction in this scenario because we've had some time to get this system going. So we would be able to, in the first cycle of corn, enjoy the rewards of our soil health that's already been kicked off. So we have a real chance for success right out of the gate. If we get a real chance good success right out of the gate, then people will stay with it, okay? This is just a Midwest practical kind of what I've, in 30 years of working with farmers trying to get this system work, that's just a Midwest model. I would encourage each of you to take these principles though and try to come up with this kind of a strategy in your part of the world, okay? So I believe that the agronomic efficiencies are optimized when soil health is maximized. I actually know that. The science would lead us down that path. However, the management is where this sometimes breaks down, and we have to understand that there's a difference when we start managing for a living ecosystem. It requires dynamic management. But as partners work together, we can take conservation further and production further if we strive with every operation and every management thought to focus on soil health. So I'll finish with, there's additional information. Our NRCS website has a lot of that Unlock the Secrets of Soil campaign. If you just Google soil health, NRCS, you'll come up with this page, and you get to see a lot of the webinars, a lot of the interviews of top farmers and people like that.